Let's continue analyzing this fourth degree polynomial, and we're to part F on the polynomial analysis worksheet, where we're asked to find the values of all possible rational zeros. So you're trying to determine now and thinking ahead toward the polynomial division or synthetic division to try to figure out which of your zeros are, or which of your possible rational zeros are actually zeros. But we got to narrow down the list of numbers, first of all, that we'll even attempt to use in our synthetic division. So the rational zero theorem states that the numbers that could possibly be rational zeros would be all rational numbers or fractions such that the numerator includes the factors of your constant term. My constant term is 1 or negative 1, and the factors of 1 are just 1 in itself. And the denominator comes from the factors of your leading coefficient, and the factors of 4 are 1, 2, and 4. And of course all positive and negative values of those, because you can have negatives times negatives or positives times positives to get those exact ratios. So what are those values? Let's see, we've got a positive 1, a positive 1/2, a positive 1/4. We've also got a negative 1, a negative 1/2, and a negative 1/4. So of all the rational numbers that you could ever think of, these were the only 6 that could possibly be the zeros, rational zeros of this function. So let's get down to business here with part G and actually trying to find the zeros. Now I know that from the first part of this problem I've got to have 4 zeros. So by the time I'm done with part G, I've got to have 4 values for x that make p of x equal to 0. I also found in part D that I'm going to have one positive real zero. One positive real zero. I'm not really sure that that one positive real zero is also a rational zero, but you know, if I'm going to be process of elimination and try to narrow down, try to decrease the amount of work, well shoot, I might as well just try the positive rational numbers first to determine if any of those are zeros of the function. So let's get our synthetic division ready. I've got my coefficients, 4, 2, negative 2, negative 3, and negative 1. I don't need any zero placeholders because I've got terms for each of the powers of x. And let's just try our positive possible rational zeros. I'll just try them in the order I've got them written. It really doesn't matter. Bringing down the 4. 4 times 1 is 4, plus 2 is 6. 6 times 1 is 6, minus 2 is 4. 4 times 1 is 4, minus 3 is 1. 1 times 1 is 1, minus 1 is 0, and hot dog, that is exactly what I was looking for. So, right now, what does that tell me? Let's see. That tells me that p of x, my polynomial that I started with, is equal to x minus 1 times 4x cubed plus 6x squared plus 4x plus 1. And it tells me that 1 is one of my zeros. So I've got 1 out of 3 zeros. And here is the factor that tells me that 1 is a 0. Now I've got a cubic factor that I need to either try to factor, which is actually not possible, or I need to try to find the zeros of that polynomial, the polynomial that's the cubic factor of my polynomial that I started with. Well, let me go back to my synthetic division. And basically now I'm going to use these 4 numbers, 4, 6, 4, and 1, the coefficients of my cubic factor, as the coefficients for my synthetic division, because I really want to figure out what values of x make 4x cubed plus 6x plus 4x squared, 4x cubed plus 6x squared plus 4x plus 1 equal to 0. Well, it's not going to be a half, because I've already found the one and only one positive real 0 for this original polynomial, and it's not going to be a fourth, because I only had one positive real 0. So, you know, the only option I can do right now is to just try these three negative real zeros and hope to goodness I find one of them. So let's try negative 1. I'm bringing down the 4, and I'm ignoring these top numbers now because those were for my original p of x. Bringing down the 4, 4 times 1 is negative 4, plus 6 is negative 4 plus 6 is 2. 2 times negative 1 is negative 2. Negative 2 plus 4 is 2. 2 times negative 1 is negative 2. Plus 1 is not 0. It's negative 1. So negative 1 is not a 0 of this function. All right, let's try negative 1/2. Bringing down my 4. 4 times negative 1/2 is negative 2. Plus 6 is 4. 4 times negative 1/2 is negative 2. Plus 4 is 2. 2 times negative 1/2 is negative 1. Plus 1 is 0. And that remainder of 0 tells me that I just found my second 0 of my polynomial. So now I know that my original p of x, if 1 is a 0, x minus 1 is a factor. If negative 1/2 is a 0, then x minus negative 1/2, aka x plus 1/2, is a factor. And then my other factor has these coefficients. And my other factor would be a quadratic factor of 4x squared plus 4x plus 2. Well, all I want to know is what values of x make that factor equal to 0, and that's just solving a quadratic equation. So 4x squared plus 4x plus 2 equals 0. It won't factor, but we sure could clean it up by dividing both sides by 2, so why don't we use this instead? And let's use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac is 8 over 2a, that's 4. So that's negative 2 plus or minus 2i over 4. So the third 0 is negative 2 plus 2i over 4. The fourth 0 is negative 2 minus 2i over 4. Both of those are imaginary zeros, so therefore these are not places where our curve will cross the x-axis, because our x-axis is only marked off with real numbers. Okay, so let's see. Now finally in part H I've got to graph this function. So let's see, back to the beginning. Let me figure out what was my, all right, my y-intercept was 0, negative 1. Okay, so that means I need to put a point at 0, negative 1. I found out that its end behavior is here. It's ending up, going up both ways for my entire domain. And then part G, I got that it crosses the x-axis at 1, and at negative 1/2. And that's it, because the other two zeros were imaginary. And so for this to happen, my function would look something like this. Now, in this class, as far as pre-calculus goes, that's pretty much all we can find out. We really can't find out if there are any more bumps and lumps and valleys and hills. That would be a calculus concept. But this, in pre-calculus, this is really all I want to know. Do you know the shape? Do you kind of understand how the analysis process works to get the end behavior, to get the y-intercept, to figure out how many times and how the function crosses the x-axis? So this, in two parts, two different videos, we've taken one 5-term 4th-degree polynomial and gone through all of the steps to sketch its graph and analyze all of its characteristics.